This is first light with the Askar 120APO. I'll tell you more about this image later on, but let me tell you about my newest telescope. This is the Askar 120APO. I've wanted this for a very long time, and I finally pulled the trigger and bought this directly from Sharpstar Optics, along with the 1x flattener and the 0.8x reducer. And I think this is the best large size refractor for two specific reasons. The first reason is portability. Believe it or not, this big chunk of thing is portable. Weighs only 6.5 kilograms, so I can lift it with one hand. I know I'm very strong. Even then, 6.5 kilograms is very lightweight for a telescope this size. It is a triplet, so it is very front heavy, so I have to make sure that when I'm holding it with one hand, I'm putting more of my strength to this part of the telescope. But once you start adding imaging gear to the back, it starts to balance out and actually feels really nice. Of course, that does add a couple more kilograms, but when something is balanced, it's actually easier to hold. And sticking with portability, this is actually pretty small. Right? If you look at it, it's not that long, and it actually gets even shorter because you can remove this little middle section here, so you can install bino viewers. So you can actually take this off and transport it if you need to. But you don't, because it gets one more point for portability because it comes with a carrying case of its own, and it looks great. I wish more telescopes did that. I don't know why they don't. And the second reason why I think that this telescope is the best, biggest telescope anyone should look into getting is the price. This thing right now, what I paid for this was $16.99. It is a triplet, so I did have to buy an extra flattening element in the back, so that costs about another $219, I think. But it was totally worth it. And when we look at equivalent telescopes or similar spec telescopes, such as the Askar 130PHQ, which is a quadruplet, which means that you don't have to worry about back focus in order to get pinpoint stars. As long as you get focus, you'll get pinpoint stars. And I did almost buy that, but for just 10 millimeters of extra aperture and about 10% more focal length, it costs $3,500. Twice as much as this thing. Not counting a reducer, but about twice as much as the Askar 120APO, and it weighs 13 kilograms, so it's not as portable. If I had my own permanent observatory in my backyard, or at least some kind of permanent setup, I would have actually sprung for the 130PHQ. But the portability of this thing and the reason that I was able to save a little bit more money than getting the 130PHQ makes this totally worth it. And I think this is the best purchase in any average astrophotographer should get if they're worried about cost and portability. Now, if you're asking why not just go for the 140APO, which is 20 millimeter more aperture, more focal length, it has its own carrying case, why not that? Well, that one weighs about 11 kilograms, so not too bad, but it costs $2,500, and it's very arbitrary, but I'm putting that out of the range. But of course, the 140APO could be in your range, so maybe that's what you think is the best large refractor anyone should get. Let me know what you think in the comments below. If I ever get my own observatory, I want their 203 millimeter refractor permanently mounted somewhere. But until then, this thing is going with me. And I do see myself taking this to star parties with me. I feel like the moon would look amazing through this. I'm sure people's minds would be blown. And I think the Askar 120APO specifically beats out its competitors. So for example, if you look at the Takahashi TSA 120, it's a super excellent refractor, but it's almost 3 times the price. And I know talk owners will say that it is worth it because the optics are excellent, and I don't disagree with you. For me personally, it's not worth it. I would love to own a Takahashi one day, but I believe that the Askar, like all Askar products, punch way above their weight class, which I always find really impressive. And with the money I saved from not getting a Tak, although I wish I could afford all of this, I got myself the Sal 33 EQ mount almost at the same time as this thing. That one arrived much later since it was a pre-order situation. So with that, I got the reducer, I got the flattener, I got a whole different mount for all less than a Takahashi. Now, there is a close second to this, which is the Stellar View 127 $3,000 doublet. And even though it's a high-end apochromatic doublet, it's still missing the third glass element that would help you remove any kind of chromatic aberrations. Not that the Stellar View has any chromatic aberrations. Stellarvue makes amazing telescopes as well, but that's just something to keep in mind, and it still costs $3,000 versus $1,700 for this. And you also need a flattener for the Stellarvue if you want to get that. So for me, the price is probably the biggest factor, and I do see myself taking this with me to Astro Adventures. Now let's take a closer look at this thing. So in front, we have the aluminum gold colored dust cap. It goes on and off pretty easily. The optics in front look amazing. Such a huge aperture. The dew shield has a locking knob in front, and it operates very smoothly, and it locks into place when I need it. It also has flocking on the inside, so stray light won't bounce off and into the interior of the telescope. Moving down, it has a 220mm handlebar on top, which doubles as a saddle for a guide scope or a mini PC or some other accessory. And on the other side of the aluminum rings, right in the middle, these aluminum beautiful rings with the locking knobs here, we have the 290mm Vixen dovetail plate. The Askar 140APO and the 130 PhD both have Lost Mandy dovetails, so if you get one of those, that's something else to keep into consideration. Moving down, we have the standard 2-speed 3.3-inch rack and pinion focuser. It operates super smoothly, and the fine adjuster is a 1:10 ratio. And this also has a very smooth camera angle adjuster here built in. It operates really smoothly and locks into place. When we take out this very smooth focuser, a little bit hard to see here, but you can see that there are markings here, as well as an arrow on the rotator itself, so you know exactly what your angle was when you were out. And on top here, we have two finder saddles. These are aluminum. These are very sturdy. Comes with two locking screws. I usually have one of my power boxes on here, but you can put a mini PC power box on here super easily. But you can also fit it right on top here. This saddle here, the handlebar saddle. And this thing comes with a visual bag that supports both 2-inch and 1¼ inch accessories. So if I take this off, you can see it has threading here that takes a flattener or a reducer. And this has the 2-inch and the 1¼ inch adapters right here. One thing I haven't done with this telescope is use this for visual. It's been really cold and nothing really good is visible from my yard these days, but I'm planning on taking this out later on, so expect a follow-up video. Now for imaging, you need a flattener because this is a triplet. The image that comes out of this tube is not flat, which means is that you will get sharp stars near the center, but as you go outwards, you'll start getting X-shaped stars. And for me, I got the 1X flattener, which gives me the full 840mm focal length at f7. And I also got the 0.8x reducer, so this will bring this down to about 672mm focal length at f5.6, which would make it much faster. I actually haven't opened this yet, still closed. I hope there's a reducer in here. Can't tell, we'll find out. And I'm looking forward to using that during the nebula season. But right now, I'm hunting galaxies, and I'm having fun with it. Now, attaching an EAF is super easy and super simple, very standard. I won't show you how to do that in this videos, but I do have other videos that show this. But if you want a dedicated video showing how to install it on this specific telescope, let me know. But you can see in the bottom here, it's very standard. Speaking of reducers, the Askar 103APO does have a 0.8x reducer, but it also has a 0.6x reducer. But the Askar 120APO, the 140APO, they don't have one. And that doesn't mean that you can't get one. According to one of my anonymous Patreon patrons, he actually got the Starzona 0.65 reducer for the Askar 120APO and reports that it works. The only caveat is that you can't really use an OAG with it because the star shapes at the very edges are a little too wonky. So that's the only thing to keep in mind, but as far as we know, it works. I do have some images that he sent that we'll take a look at in the image analysis section so you can see exactly how things look. Now the question on your mind is probably, how do the stars look through this? Keeping in mind that I only tested the 1X flattener, so I'll have to do a follow-up during nebula season with the 0.8x reducer. Let's take a look at some of those images. Right, we're going to look at some aberration data here. So this is actually, we're working backwards. This is the 0.65x reducer sent to me by my anonymous patron. And if you look at the image aberration inspector, we can see that the stars in the corner, it's pretty dim. In this view, we'll take a look at it again in PixInsight. It looks pretty good, even with the dim stars. They look pretty round to me, although maybe a little bit of elongation. But this was actually a test from trying out the back focus adjuster here anyway. So let's take a look at what an image looks like of M81, M82 that I captured with the 1X flattener. So if I do image inspector here, you can see that the stars, like on the edges, they look perfectly pinpoint stars. Where I aimed this telescope this time, there's not a lot of stars over there, but even what we can see here, it's pretty good. Yeah, like this, it looks great in perfect sharp star optics fashion. It has sharp stars. Looking at this data in Photoshop, so this is the 0.65x reducer. The data looks really good. The stretch here is a little bit better. You can see the stars have good shape. Field of view is so wide, and we can see a little bit of vignetting around the edges, but I think that's expected. This is also why you probably can't use a OAG, and also why probably, I'm speculating here, that why Askar did not make their own 0.65x reducer. If you look at my data of M81 and M82, here's a single non-debayered file. The stars look perfectly normal everywhere. This is a binary star almost touching there. Yeah, this looks really good. So if you look at a standard stacked one, so this is stacked RGB, just with my OSC camera, the two galaxies look really good. Lots of great detail. This is 441 minutes of data. We can see stacking artifacts around the edges, but those get cropped away. You see some really nice tiny galaxies here, and another one over here that is certainly getting cropped off. And we have Garland Galaxy here. If you look at the narrowband stack, looks a little bit sharper just because of how the filter works. And M82 just looks incredible. This is just a stacked version, not processed at all. You can see all this noise around here. And when we do process everything and we put them together, we can get something like this. I may have made the background a little bit too dark, but I tried bringing out some of the IFN and I failed, so whatever. But this is hydrogen alpha integrated with the RGB, so a lot of data here, about 17 hours, and we can see some really nice H alpha regions on M81. If we scroll down to M82, this is where so much of the magic is, and taking an image like this was something that I've wanted to do for a very long time, and I was able to do this from my Bortle 8 backyard with the Askar 120APO and the ASI 2600 MC Pro and a dual narrowband filter, just 7 nanometers. Makes me want to redo this in mono. I think you can probably tell how I really feel about this telescope just from what I've said so far, and I really, really, really like it. I have no regrets buying, well, I actually wish I bought this earlier so I paid a little bit less and I had more time imaging with this, but I really like it. I'm glad I got this, even though I paid a little bit more than I would have otherwise. And I think that this is both built really well and priced really well for both beginners who are looking to get a larger refractor, as well as advanced astrophotographers who are looking to get a large refractor that can help them push their skills to the limit. I can definitely see myself sending something like this into a remote observatory at a dark site to get really nice and fine details of galaxies and small nebulae. And with the reducer, you can get larger nebulae, which is kind of amazing. And since I have the SAL 33 now, I actually have 2 mounts and I can afford to send one away to a dark site somewhere. If you have thoughts on that, if you have experience sending your rig to a dark side observatory, let me know. I'd love to hear your thoughts. And like I said, I plan on making follow-up videos, including how this performs with visual astronomy. I would love to take this out to a star party one day and let people observe the moon through this. I think it will look fantastic through this. I also want to do some solar system imaging, probably the moon, maybe the sun, make a solar filter hat for this, and maybe a comet if one comes by, and see how it does there. And of course, there will be a quick follow-up when I get the chance to use the 0.8x reducer on Nebula in a couple of months. If you have a question about this telescope that I did not answer in this video, or you can't find from any other reviewers or online, please ask in the comments below and I'll do my best to answer you. Again, thanks to Sharpstar Optics for working with me and sending me a unit directly, and a huge, huge, huge thanks to all my supporters on Patreon, Buy Me a Coffee, and on YouTube for their trust in me and for their support. If you'd like to support me on the work I do, consider checking me out on these platforms linked below. Thanks for watching, and until next time, clear skies.